So we'll start in some time. Let people join in. Fine.
Install, like, should they download the GRE file again?
You don't need to download it again. So I do believe we can start with the introduction and stuff. So, hey guys, myself Arjun Muturaj, along with my fellow presenters Yashvardhan and Santosh, will be conducting today's session on Introduction to Digital Design. So, in the first half of this session, we'll learn the basics which will be required for learning in depth about digital design. So, many of you might already know these things, but yeah, it will be a quick revision for you guys. So, yeah, let's look at what we'll be dealing with today. This is the table of content. As you can see, these are the topics which we'll be covering in this session. Without wasting any more time, let's start with the introduction portion. So, electronics that deals with circuits that use digital signals and logic gates to process, manipulate, and store binary data. In digital electronics, information is represented in the form of zeros and ones. So how is it different from analog electronics? So analog electronics, on the other hand, deals with circuits that use continuous signals to represent and process information. Uses voltage values that can take any values in a particular range. So yeah, moving on. So let's look at some applications of digital electronics. Firstly, computing devices such as computers, smartphones, tablets. They operate on binary data using logic gates and digital circuits to perform calculations, execute instructions, and as well as storing data. So yeah, even in communication systems, it is widely used. Data is transmitted and received using binary signals. So binary signals are used since they are less influenced by noise and interference. Hence, data sent and received is pretty accurate. So if you might remember, we used digital signals while working with I2C SPI and UART also. So yeah, moving on. What exactly is digital design? So, digital design refers to creating and implementing digital electronic circuits. You can go through the definition. So yeah, the creating and implementing is a keyword here. Okay. So yeah, some of you might feel that the lecture is going too fast, but it's just the basic introduction. So it's a revision for some people. So it's going to be a little faster than normal, but yeah, pay 100% attention to it. Okay, it will be fine. Okay, so let's learn about the number systems which will be necessary and also conversion of one number system to another. You might have heard that computers only understand ones and zeros, right? So yeah, that's why binary system is very essential. So here the base 2 represents that it has two values, 0 and 1, where 0 is off and 1 is considered to be on first, okay? Before that, I'll explain what MSB and LSB are. So MSB does not stand for mechanical sciences block, okay? So MSB stands for mechanical sciences block, okay? So MSB stands for most significant bit. So MSB stands for most significant bit, and the LSB stands for least significant bit. It is the rightmost bit with the lowest value, which is 1010 into its decimal equivalent. Position from the right gets the value 2 raised to power 0. As you can see, 2 raised to power 0, 2 raised to power 1, 2 raised to power 2. So the first position gets the value of 2 raised to power 0. So in while converting you don't have to do the task for this session. So yeah, I'll give a hint regarding the question first. Like as you can see a pattern, right? You can see like 2 raised to power 6, 5, 4, 3, 2, 1. Hint, okay. So I'll show the question in a while. So get ready with your notebooks. Take a picture of the solution and make sure to send it on the WhatsApp group. The first two people who send the right answer won't have to do the task for this session. They will be exempted from it. So yeah, if everyone is ready, please give a thumbs up. No, it's not a trap, Subhadeep. Yeah, 3 point. This is the you have to convert this, okay, from binary to decimal. I'm checking the WhatsApp group for any answers. Take your own time. It's fine. You don't have to send the answer. You have to send the whole solution. Okay. Okay, we got some answers. Okay, we got the first two right answers, Satvik and Kalyan. Good job. Nice seeing everyone trying. Nice, nice. Fine, we'll look at yeah. So yeah, the solution is 42.6875. Yeah, so let's look at how we can do it. Okay. So yeah, it's similar like the integer portion first. So yeah, it's like the normal. Let's see how we can do the fractional portion of it. Okay. So yeah, 1011, right? So the first position towards the right. So we multiply 1 into 2 for okay. So yeah, after summing this 42.6875. So yeah, I really appreciate that. So yeah, moving on. Kalyan. So yeah, moving on. Let's look at how to convert a decimal to binary. Okay. So we use long division method to do so. Uh, let's say the number is 14. Decimal number is 14. First, we'll divide it by 2, which will give us 7, and the remainder. We write the remainder. The remainder is important. We use the remainder to write the final solution. So make sure you write the remainder on the right. To
Arjun, sorry for interrupting. Are you sharing the screen?
Yeah, I'm sharing the screen.
Currently,
Is
there
it not
is no
visible?
screen of well, like visible on the YouTube stream. So just to make sure,
Is it not?
like, does the Canvas app have any security policy because it was not showing it on the YouTube thing?
I mean, it was. Dheeraj,
Like
try.
also like try downloading the presentation, right? Are you showing it on the web or you are doing it on your desktop or anything like that?
Then repeat.
Like, are you presenting it from the Canvas app itself?
Yeah, I'm presenting it from there itself.
Like
So it will
Arjun,
be
would you?
recorded in the meeting.
But it's not visible on the like YouTube stream.
Dheeraj, try. Is the window visible though? Like the Teams
Uh,
window, is it visible?
it is only that is